All right, well, good morning, everyone. Thank you for joining Flex Train, a flexible training opportunity brought to you by Johnstone Supply. So we talked a little bit about load calculations, and we didn't really want to dive very deep into load calculations because that's a very specific niche in our industry that really you need to be qualified or at least spend some time doing some formal training to do load calculations and understand what load calculations are, because it really is the basis of determining the entire load for the house and the equipment sizing. And that's something that we don't want to take lightly. We want to make sure that it is completely understood for calculating the load on a structure. So as we have moved from calculating a load capacity on a structure into designing our ductwork, we need to at least be able to take a small portion of that and look at duct sizing and duct calculators to make sure that we're selecting the proper duct sizing for the airflow that we need. So when we talk about duct calculators, there's a few options for calculating that. So there are folks that like to use online calculators. So a lot of people who spend time on their PC, especially engineers and product managers and equipment designers, they're going to be using functions like these where we can actually input our dimensions and we can do quick calculations from those. And there's a variety of different online duct calculators. If you're using the mobile apps, which I tend to use a few of them, I use that S&P Utilities on the right-hand side. But there's a lot of common ones. That super cool slide rule, that's a very good free duct calculator that you can use. Bluon is a company that is really starting to take a big hold in the industry. You're going to see a lot of stuff from Bluon in the next year or two. And these are all free calculators, and they don't have a lot of advertising to them. Some of them don't dive too deep into the duct design, but most of the time we're just looking to get typical dimensions off from our equipment, off from our ductwork, right? So we don't have to get extremely specific on it. We just need to have the correct size based on our CFM. Well, if you want to get deep into calculating these, you can actually get into some of the paid mobile apps. There are a variety of them. I would recommend of any of those, probably the ASHRAE HVAC duct calculator, anything that is tied directly to the industry and has updated analytics and statistical information. But that's going to be entirely up to you. So there's a variety of duct calculators that you can use. As you all know, I'm pretty old school. I like using my manual duct calculators. As we start taking some pictures here in a minute of mine, you're going to see that even my newest one is a little torn up because I use it all the time. I keep one in my backpack. I keep one in the console of my truck. And there's a variety of different ones out there. And to me, it's the easiest way to look at my duct calculations because there's a lot of information on a duct calculator. Most people use a duct calculator simply for looking at one size for their duct work and getting a rough estimate on the duct size that they need. But there's a lot of detailed calculations on a duct calculator that is very important to our industry. You're going to find formulas on that thing. You're going to find some conversion tables, and you're going to find weight. You can actually look at the weight of your ductwork based on its dimensional sizing and its gauges. And it's all in these pre-built duct calculators. So if you do not own a slide duct calculator, it's time to invest in them. They're very inexpensive, and some of your distributors will provide those for free, or particularly if you're in a class. If you're taking one of my duct design CEU classes, you end up getting a duct calculator from heating and cooling products. So I buy a whole mess of them, and you end up with your own duct calculator because it's crucial. So many times we encounter in our industry ductwork issues, undersized ductwork. I mean, how many times have we went on a job and we've had high static pressure, right? It's because of poorly designed and poorly sized ductwork. I actually went on a call here about 2 weeks ago. It's actually a friend of mine. He had a question about a contractor that was getting ready to install some ductwork in his home. He had a Victorian home that had an unfinished third floor to it, and they had already installed the equipment. They were getting ready to lay the ductwork out, and he had some concerns about the sizing of ductwork that the contractor was using. So I went over and I took my duct calculator and took my tape measure and immediately found that it was incredibly insufficient for what they were trying to accomplish. And because we were able to catch that before the installation, we're able to correct that so they would have a properly flowing system. And when the homeowner asked the contractor, what were the dimensions that he was using, how much CFM was he calculating through his ductwork, he didn't even own a duct calculator, and this was a licensed contractor in the city of Indianapolis. So it just goes to show that even some of the better contractors are not doing things properly. And that's what we're here to do, is just to help you understand things a little bit easier. So if we take a standard duct calculator, some of the most important functions are just on the face of it. And this is what most people use. And this is what I use most of the time. So let's stay here for a little bit. So if we're talking about a slide duct calculator, we're talking about a two-part function, right? We have an inner slide, and if you ever take that slide out, if you've never taken the slide out of your calculator, you're going to find that you also have more information on the back side of your slide. So it's a lot of information in one little tool. So instead of carrying an engineering book around with you or an HVAC instructional book, you can keep a duct calculator and find most of the things that you need. So let's look at some of these things. All right, so if we're wanting to find out how much airflow can be ran through a duct, we're typically looking at that based on static pressure, right? And we all know that manufacturers of HVAC equipment, unitary equipment in general, they design their blower motors around 0.5 inches of static as being ideal. So whether that is a permanent split capacitor, whether that is an ECM constant torque or an ECM variable speed, they design those for around 1/2 inch of static. But what we're seeing in the industry is as we are getting more efficient in our equipment, the static drop across our equipment is starting to increase. If we looked at a coil, we talked about this just a few weeks ago. If we talked about an A coil from the 1990s, a 10 SEER or so, we typically had about 0.1 inches of static drop across that coil. Now, because we're trying to shorten these coils to get those to fit in our shorter applications, we're adding a lot of resistance across our coils, and we're now looking at higher filtration than we looked at 20 years ago. In the past, we would look at a 1-inch filter as a pretty good filter. We may install a 3-inch or a 5-inch, but that was pretty much that was an upgrade. That was not a common installation. Well, in today's industry, our common installation is going to have a multi-inch, a thicker pleated filter for the installation. And when we look at our coils, we have wet and dry calculations for those coils. And what you'll find, and Jesse and I just encountered a bunch of them here just last month. We were looking at the wet bulb wet calculations on an A coil and found that some of our coils on our high efficiency equipment had like 0.37 inches of static across that coil, 3-ton coil. So that doesn't leave you much room for failure, right? So if we talk about 0.37 across the coil, we're going to talk on, and now if we get into a high efficiency furnace, we're going to add another probably 0.15 across the primary and secondary heat exchangers. And then we had a filter, which is going to be a 0.1 or so on top of that. We could very easily be marginal on our 1/2 inch of water column without even adding ductwork, which is why some contractors are now moving away from high efficiency furnaces on these high capacity, high efficiency air conditioning and heat pump combinations. It's because of that additional static drop on that secondary heat exchanger. We didn't design our ductwork for high static across our coils or for secondary heat exchangers. Remember, most of the ductwork built in our houses, especially if you own a home that's 20 years or older, it may not have been properly sized for air conditioning, let alone a secondary heat exchanger on a high efficiency gas furnace. So our ductwork is just not sufficient enough. That's why most of the country has gotten away from ducted systems and have went ductless because of these kind of issues, static pressure issues. So say we've got a situation, we got to figure out why we're having issues with our duct system. Well, now we need to be able to calculate the actual airflow that we can put through our ductwork. So let's take out our duct calculator. If anybody has one, grab it and we'll kind of walk through as we go. I've taken some of our slides and highlighted a little bit so you can see what I'm talking about. So if I take my duct calculator and let's just say, just for reference out of this, we're going to be looking for approximately 1,000 CFM. So we've got a 2.5 ton air conditioning system. And we want to see what size ductwork we need to be able to run on that 1,000 CFM. Well, here's the thing. I can move 1,000 CFM in a variety of different sizes of ductwork, but it's going to affect the static pressure that is on that. When we talk about static, we are literally just talking about how much pressure is on that. If we go back to the fundamentals of static pressure and understanding what we're reading, do we all remember how we originally read static pressure? We took a 1-inch tube, a 1-inch glass tube. That's all. 1-inch tube, put it in a U-bend, and we put water in it. Plain water. Distilled, hopefully, but a lot of times it's tap water. And we hooked up a hose on each side of that, right? That was our manometer. That's what told us how much pressure we had on our ductwork. We would simply take that hose and connect it to our ductwork. And then our ductwork would push on our water and we would move. That's why when you see WC, inches WC, that's inches of water column. That's how far we were pushing or pulling the water inside of that U-tube, that 1-inch diameter tube. So now we do this with electronic tools, right? We use digital manometers to do this, but we're reading the same thing. We're reading how much pressure is being exerted on that ductwork. So I try to design my ductwork around 0.1 inches. Typically on my supply, I'll do 0.1, and on my return, I'll do 0.08. But 0.1 is typically where I design my ductwork. So if I'm looking for a piece of ductwork to connect to my blower that will move 1,000 CFM of airflow and only have 0.1 inches of static on that, this is where my duct calculator comes into play. So I set my slide to 1,000 CFM, around 0.1 inches, and now I can have a variety of different sizes of ductwork that I can use to accomplish that. If I'm going to use round ductwork, you'll notice that I am just slightly under a 14-inch round. So I can't go down, otherwise I'm going to add additional static to it, right? I can only go up. So in this application, I'm going to use a 14-inch round to be able to move 1,000 CFM at 0.1 inches of static. Here's the kicker with all this. This is assuming that we're using approximately 100 feet of ductwork total. And most of the time we are. So a duct calculator most of the time is going to be plenty sufficient because most residential applications we're not going to be using over 100 feet. Now that's including your elbows and that's including your boots, and we'll talk about that here in a second. But this is assuming approximately it's per 100 feet. Now, I'm going to use a 14-inch round. So if I needed to move 1,000 CFM on this system, I can use a 14-inch round on my supply or my return. But what if I'm not using a round? What if I need to use a rectangular duct coming off from this? And I just simply want to move the same amount of air. That's where we move over to the other side of our duct calculator, and it will give us the accompanying dimensions in rectangular. So I can calculate a round and I can calculate a rectangular in multiple dimensions. So if I'm looking at my rectangular duct, that exact same unit would give me an 8 by, if I look at that, I'm slightly underneath 22. So I would have to go with an 8 by 22. But I could also make other dimensions out of this. Let me grab my highlighter here. I'm going to back up and get these arrows off from here real quick. Woo, get back. If I wanted to make a custom duct, so maybe I was trying to get through a space where a standard 8-inch or 10-inch isn't going to fit. Well, all I have to do now is figure out what else do I want it to be. I could be a 10 by, so that's slightly over 16. So I need to be slightly over 16. So 10 by 16 and a half. Or I could do a 5 by 40. I could do a 6 by 30. I could do an 8 by, so there's actually almost 21 and a half, 8 by 22. I could do a 15 by 11. I could do a 1/2, 3 1/2 by 60, right? So this is the issue that I got into with this other contractor. He was wanting to use wall stack to run 6-inch registers. Wall stack is 3.5 inches. So I can run a bunch of airflow in a 3.5-inch cavity inside between two studs. But if I needed to run 1,000 CFM between those studs, I need 60 inches between those studs, 5 feet between those studs to be able to move 1,000 feet unrestricted. So, using that duct calculator, you're going to be able to come up with all sorts of options, all sorts of custom options to be able to make this system work and move air properly. Get rid of my highlighter here. Oh, there's that slide. All right, so let's take a real quick poll. How many CFM is a 6-inch round duct good for? Let me launch this real quick and let's get an idea. Because in our industry, we tend to get trained into a mindset because we are learning from people who have learned from other people who have been doing this industry for a long time. And what we find is a lot of the information that we have received is not always accurate information. It's technically correct information, but not exactly accurate. And this is exactly why I like doing these classes. This is why I love for you to join us and be a part of this experience, because you're going to find things that you've never been taught before. So if I look at that poll, we had an exact split, 50% saying 100 CFM and 50% saying 110 CFM. Here's why. As a rule of thumb, and that's all that it is in the industry, as a rule of thumb, a 6-inch duct is good for 100 CFM in the industry. I will tell you that a 6-inch round duct is good for a variety of different CFMs. It just depends on how much static pressure you want to put on that thing. Because if I look at this, if I look at my duct calculator, I'm going to grab my highlighter here. I'm going to set my duct calculator at 6 inches, right? So set my duct calculator for 6 inches. Actually, let me take this off here. I think I have another slide that has that. Let me make sure before I get too carried away here. Nope, okay. Set my duct calculator to 6 inches. 6-inch round. By the way, how much airflow can I put through that 3.5 inch? At the same equivalent. There's 3.5. It actually be 3.5 by 9. So 6-inch round is the same as a 3.5 by 9. It's probably going to be a 3.5 by 10, but 3.5 by 9 is the actual calculation for that. So if I wanted to run the equivalent of a 6-inch round through a wall, I just needed to have a 9-inch wide cavity. So remember me saying that I set most of mine at 0.1 inches. So I'm going to set most of my calculations at 0.1 inches, right there. And that would be good for about 110 CFM at 0.1 inches. But if we also look at that exact same chart and go, okay, well, what if I have higher static on my system? How much airflow can I get out of that 6-inch round? So Jesse and I have been on jobs where we've encountered over 1 inch of static on ductwork, right? Unfortunately, it happens in our industry. Well, if I had actually designed my ductwork and I had a blower capable of doing it, and I had a true inch of static on that particular duct, I can squeeze a lot of air through that thing. I could actually squeeze at 1 inch 380 CFM through that same 6-inch round. That's a lot of airflow.
Mm-hmm.
That's almost 4 times the airflow that I have designed it at. So here's the consequence. What happens when I put an inch of static on a duct? I have a lot of noise. And I have a lot of pressure on my blower motor. My amps are going to be going up on my motor. My heat is going to be going up on a motor. And out of the experience that we're seeing, even with our ECM variable speeds, the best motors on our industry right now, 3-phase motors that are fully modulated, above 0.8 inches, these motors start overheating and they start freaking out, and they will shut themselves down and protect themselves.
Mm-hmm.
So we have to stick to our guides of airflow. We have to keep these systems around 0.5 inches. So we need to design our ductwork at 0.1 inches and lower to be able to maintain these standards. So if you're setting up your ductwork properly, you can get all sorts of airflow. Just make sure that you're setting it up properly, because it can go just the opposite direction. Because you may get engineering specs that has, that your supply ductwork needs to be designed at a 0.05. I have seen 0.05 engineering specifications before. 0.05 on a 6-inch round is now good for 75 CFM. So if I'm designing the ductwork for this entire structure, and my engineers told me that I can only have a 0.05 on my supply, I have now went from 100 to 110 CFM all the way down to 75 CFM on that same 6-inch line. So we have to set our ductwork proper. We have to set it for the static that is on our system. So it's just a different mindset when we start looking at duct calculation and static pressure, because we can't say a 6-inch is good for 100 CFM. We can't say that a 10-inch is good for 400 CFM. We cannot use those. Those are just rules of thumb. And as our static changes, so does the airflow. And the length of our ductwork is going to be a huge factor as well. So we have additional charts that helps us out with that. So we can look at capable airflow that can be put through different transitions and different elbows and branches and risers. And we can also look at how much restriction is in fittings. So there's 2 ways. They actually go hand in hand if we're looking at ductwork. You can design it by individual runs, which is where we would take our duct calculator and go, okay, so on this 6-inch run, I want this much. That's not calculating, though, the restriction that is going to be in the takeoff coming off from the trunk. That's not taking into account restrictions that's in transitions, in elbows that are horizontal elbows or vertical elbows. That's not taking effect of any boots. So now what we have to do is we have to actually add all of that together. If we're going to do this properly, we need to take all of our fittings and we need to start adding those as part of our total duct system. This is where you get into your effective length. This is where you start looking at your entire duct system to see what size you actually need to use. So if we look at some of these boots and we're going to start adding feet, we add, so we would add up our total ductwork. And then when we start adding in our fittings, so if I use a straight boot, there's not a lot of restriction on a straight boot. So that's equivalent to 5 feet of ductwork, right? If I'm using a 90, man, 6 times as much restriction on that 90 boot. How many people actually would think about that? Stop and look at your design and go, okay, if I come straight out of the bottom of my boot, I've only got a 5-foot restriction. But if I put a 90 on there, I'm going to have a 30-foot restriction on this thing. And that's what happens in our industry. We don't look at these restrictions enough. And if we took the time to look at those, we would find that there's a lot of restriction in our elbows and in our boots that are not accounted for. If we properly account for these, if we truly want to get an exact representation of what our ductwork is, we have to go to the back side of our chart. We have to go to the back side of our duct calculator and use the chart that is almost never used. So Paul and I got together on this one last week because I wanted to do this class, and I stopped for a minute and went, man, I've seen that chart and I've not really used it much. And I called Paul. I was like, Paul, you got a good answer for this chart? And he's like, I haven't used it enough either. So I called everyone that I knew, and everyone said the same thing. It's like, well, I've never really taken into account that much of a change. I go, yeah, no, me neither. So let's look at what we're actually doing, because it helped me rethink my ductwork a little bit. What this chart is actually saying is that if we're calculating for 100 foot of duct length, and then we're going to start adding all of our fittings and elbows into that, it can change the amount of pressure drop. So as we start adding all of our links together, we have a calculation that needs to be changed. Because if I have a duct system that has all boots that are coming out of the bottom of it, it's probably not going to affect my total pressure. But if every boot in my installation is a 90, and we're trying to keep those tucked up into the floor joists really well, it adds a lot of restriction to my total system. So what I can do, if I want to get an accurate representation of how much restriction is in that system, I can use this corrected pressure drop calculation chart on the back. And what it's going to do is it's just going to tell me how much to correct that pressure drop so that I can change the size of my ductwork accordingly. So if we're calculating from 100 feet of duct length, we're typically not going to have to do much recalculating. But as we start increasing our duct sizing beyond 100 feet, we have to do some correction factors so that we get the proper size duct for the CFM that we need. So it's a good chart to go over. It's a good thing to understand. I know it's a lot of information on duct calculators. I'm going to open up all of the lines. Does anyone have any kind of questions on duct calculators? Or anything that you'd like to add? Bunch of shy people this morning. All right. Well, I'm gonna go ahead and wrap things up and say next week, and then on December 31st, I'll be here in the morning. We're going to do an actual duct calculation of a residential ranch system, and we're going to look at all the dimensional layout of the ductwork so that we can understand duct sizing from the plenum all the way out to the final registers, and then we can look at it backwards from the registers back to the plenum, because there's two different ways that you can size, and I've always determined that it's either a left brain person or right brain person, whoever's dominant on the left or dominant on the right, whether they start from the plenum and work their way out, or they start at the out and they work their way back. Because I have had both in class and they both come up with the same answer. Some prefer to start at the furnace, some prefer to start at the boot. So we will discuss all that, and we will lay out an entire duct system using a duct calculator. So I look forward to that, and I will see you all next week on FlexTrain.